Flipped classroom video for Maths A2 Unit 3, Modulus Equations. Let's have a look at a basic modulus equation. So from before, you might remember this from the previous video, we had this graphing of y equals mod 2x minus 3 and graphing of mod 2x minus 3 take away 4. And I mentioned at that point that we would generally try to identify those points where this y equals mod 2x minus 3 take away 4 is crossing the x-axis. So I suggested at the time you might want to have a go at it, and maybe you have and maybe you succeeded, but let's have a look at how we would do it in case you haven't. To identify the points indicated, since they have a y value of 0, we need to solve mod of 2x minus 3 take away 4 is equal to 0. And that means we're trying to solve mod of 2x minus 3 equals 4. Now, for the mod of 2x minus 3 to equal 4, because mod of 4 is 4 and mod of minus 4 is 4, we can split this into two equations. We either have 2x minus 3 equals 4 or 2x minus 3 equals minus 4. That's because either of those, if we mod the right hand side, we would get plus 4, which is what we want. So solving those, the first thing we do is we add 3 to both sides. So on the left hand side that gives us 2x equals 7, and on the right hand equation we have 2x equals minus 1. We then divide by 2, so we have x is 7 over 2, or x is minus a half. And if we look on the graph, those answers look reasonable. The one just to the left of the y-axis, minus a half, looks okay, and the 7 over 2 looks okay. Bearing in mind it's only a sketch that we've got, but they look reasonable as answers anyway. Now there is an alternative method as well, and that is squaring both sides. There's a sort of obvious relationship between modulus and squaring. Modulus makes numbers positive, and squaring makes numbers positive, makes negative numbers positive as well. So it's not a big surprise that they may be related in terms of solving these problems. So what we can do is that we can say that if mod of 2x minus 3 equals 4, then 2x minus 3 squared equals 4 squared. If we then multiply that out, we get 4x squared minus 12x plus 9 equals 16. 4x squared minus 12x minus 7 equals 0. We can factorise that. You can work through the factorisation for yourself separately if you wish, but that gives us 2x minus 7 times 2x plus 1 equals 0, and of course we get the same solutions as before. So x is either 7 over 2 or x is minus a half. Now before we said the answers look reasonable, but one thing of course we can do also always with answers is check them back in the original equation, and if we put 7 over 2 into the original equation, we get 2 times 7 over 2 is 7, 7 take away 3 is 4, modulus of 4 is 4, 4 take away 4 is 0. If we put minus a half into the original equation, we get 2 times minus a half is minus 1, minus 1 take away 3 is minus 4, the modulus of minus 4 is 4, and again 4 take away 4 is 0. The tricky thing with the squaring method is it can sometimes give phantom roots, so it'll give answers that don't work because of the difference between squaring and the modulus, and it doesn't work quite the same. So you've got to be careful, and generally we would avoid this by sketching a graph to make sure that we're not picking up one of those phantom roots. Now, modulus both sides. Moduli of some functions. So we've got the modulus being involved with more than one function. So here we've got the modulus of the function 2x minus 5 is equal to 3 times the modulus of the function x plus 1. And that means because the 2x minus 5 could be positive or negative. The x plus 1 could be positive or negative. You might think, well, there's 4 different cases, but actually there's only 2 cases, because if 2x minus 5 is equal to positive 3x plus 1, that's the same as the negative 2x minus 5 being equal to the negative 3x plus 1. And similarly, with the other possibility, which we have the negative 2x minus 5 equals the positive 3x plus 1, that's the same as the positive 2x minus 5 being equal to the negative 3x plus 1. So we only have to look at 2 cases, and we can work through them. So once we've made that initial decision of what does the modulus mean to these equations, often the actual equations are pretty simple, really. So with this one, we've dealt with the fact we've got mod on both sides by saying, well, we need a positive equals positive or negative equals positive. Those are the 2 possibilities. Then we can just solve the little linear equations that arise quite easily. So 2x minus 5 equals 3 brackets x plus 1. That means 2x minus 5 equals 3x plus 3, which means that minus x equals 8. So we've subtracted 3x and added 5 to both sides, and x is therefore minus 8. The alternative is that we have minus 2x minus 5 in brackets is minus 2x plus 5, and the 3x plus 1 equals 3x plus 3. Then we subtract 5 from both sides and subtract 3x from both sides. That gives us minus 5x equals minus 2, and x equals 2 over 5. Now alternatively, we can square both sides. Now that gives us 2x plus 5 squared equals 9x plus 1 squared. The reason we have the 9 is that everything has to be squared, including the 3. That means, multiplying out, we have 4x squared minus 20x plus 25 on the left hand side. We have 9 times x squared plus 2x plus 1 on the right hand side. And the right hand side therefore becomes 9x squared plus 18x plus 9. We can then tidy up, we subtract the left hand side from the right hand side, because we want a positive coefficient for x squared. That gives us 5x squared plus 38x minus 16 equals 0. And again, I'm just going to write the factorisation down. You know how to factorise quadratics, so you could do that by whichever method you prefer. Either way, we end up with 5x minus 2 times x plus 8 equals 0, which gives us, of course, the same 2 solutions as before. X equals 2 over 5, comma, minus 8. Now, I mentioned that the squaring method can cause difficulties. It clearly hasn't in this case, but nevertheless, it's worth having a look at sketching. So, we draw our axes, we put on y equals 2x minus 5. So to do that, we just identify the points where that line crosses the axes, and there it is. We know we're going to do the modulus, so we just do a dotted line for the part that's below the axis. We put our positive 5 to reflect the minus 5 and draw through. So there's our 2x mod 2x minus 5 on there. Now we're going to look at 3 brackets x plus 1. That would go through 3 on the y axis and minus 1 on the x axis, so that's there, and then we reflect again. What we can see now is that the intersection we can see looks like it's the 2 over 5 one, and that looks pretty reasonable. It's quite close to 0. We can also see, because of the different gradients, that the red line is going to hit the purple line somewhere in the negative x region, and minus 8 looks reasonable for that, because it's going to take a while for them to gradually get closer together and meet. So that sketch makes us feel reasonably confident that our answers are okay. They're not ridiculous, at least. Okay, we're going to look at the modulus of x within an equation. Modulus of x versus modulus of f of x. So what we can do is treat mod x as a variable and deal with the modulus at the end. So we might have a situation like this. So we've got 3 mod x plus 1 equals 2 take away mod x. And this is much easier than you might think. We can just, as it says, treat it as a variable. So we just add mod x to both sides, giving us 4 mod x plus 1 equals 2. we can then take away 1, so 4 mod x is 1, and therefore mod x is a quarter by dividing 3 by 4. That means that x itself is either a quarter or minus a quarter. And again, reiterating a sketch is always a good idea for these questions, these modulus questions, and most questions really, most questions that have a geometric element to them. And we can see here, this is clearly not a sketch, but I've done it on GeoGebra. It also shows us that GeoGebra can handle moduli. And we see that we have 3 mod x plus 1 in the brown and 2 take away mod x in the green, and we can see that they do indeed meet at 0.25 or a quarter.